Yeah, hello Pratham, am I audible to you?
Good evening, sir. You're
Yeah,
audible.
good evening Pratham. So, okay, so today we'll be starting with your electric fields. I think lecture 3 I can do. Yeah, electric. Did you revise the previous topics which we discussed?
Yes, yes, sir.
Yeah, basics and the Coulomb's law. Any problems solved on the basis of this?
No, sir. No problem.
Okay. So, any doubt till now? Hello
No, sir.
Pratham, any doubt you have till now?
No, no, sir.
Okay. Yeah. So, did you went through this problem?
Yes, sir.
Okay, that's fine. I'm not taking it right now. Okay, one topic is specific for this one, so in that at that time we will discuss about this. Okay. Yeah. So let's close the notebook. What is electric field? Today we'll be starting with it. Okay. So, what is this here? We have electric field. What is electric field? Generalized idea will be taken first. You have a charge, right? A normal charge. I'll say that you. This charge have some area, right? Have some area. We have another charge. You know, both charge will uh, provide some force on another one, right? They'll be having some force between them.
Yes, sir.
How the force between them is there? Like how I'll be defining till what level the force can be observed. So then we comes up with a field. Okay. If I say before going to this, let's move to the single charge. I can say the area, right? If I'm placing a single charge at some point. All right. Before going to this, what we have discussed till now, you know that for an electric charge to have an electric field, basically to have an electric force, you need at least two charges, right? So that one can apply force on the another one. Is it clear?
Yes, sir.
Right. So a single charge will never experience any force. This is one thing we
Yes,
know,
sir.
right? So if I'm placing another charge on at this point, so it will there will be some force. There will be some force, like but how this force is applied to this? For example, earlier I had only this charge. Okay, so you know it was a single charge. On single charge, there will be no force, right? There will not be any kind of force. So how I'll say that? Yeah. So now I am bringing another charge. Okay. You know there will be force, but how? What are the reasons why there is a force stabilized in between them? When it was single, there was no force, but when I bring another charge, there is a stabilization of an electric field or electric force in between them. What's the reason behind that?
I don't know.
Yeah, like what's the reason behind that?
I don't know.
Okay, no problem. So what we are going to do is, let's say when there's a charge, what happens is it provides some electric field outside. Okay, let's say this is a field.
Yes,
Electric field is nothing but a reason around which it can experience electric force, you can say. Okay, so let's say this
yes,
is the reason. Yeah, okay, here. So let's say this is an electric field reason. You can see right now there is no force, like there is no other charge in its electric field reason, right? So it won't experience any kind of
yes, sir.
force. But what I did is I
Yes,
pull this charge, I grabbed this charge and take it to this place. Now you can see this charge in the region of this electric field, is it
yes,
right? Also, this charge will also be having some its own electric field
yes.
like this. One more thing to be noticed here, I have intersected that, but electric field lines can never intersect. Okay, this is one thing you have to remember. Electric field lines can never intersect. Can never intersect. Okay, there won't be any kind of intersection in between them. Okay. So basically, what is the electric field? Electric field is nothing but the region around a charge where it can experience some kind of force over it. Understood?
Yes.
Okay. In another word, space around a charge in which its influence can be felt by any another charge particle. You have a network problem, I think.
Hello?
Yeah, you have network problem. Like your signals are showing red over here.
I don't know why. Let me check my internet speed.
If it is like you can reconnect the session if you want. So we'll continue.
So can you repeat?
Okay.
Speed is quite low. Just give me a second. Yes, so what about now?
Yeah, Pratham, you have joined, right? So let's continue with the session.
Are the signals good now?
Yeah, I think now your connection seems good. Okay,
Okay.
let's continue. You can hear my voice, right?
Yes, sir.
Okay. So yeah, what I was saying is, this is one thing I want. I didn't write any definition for this, so I'll just write that first. So finally, I'm going to write the definition of electric field. Yeah, it's basically the reason around any charge, around any charge in which, around any charge in which what we are going to happen. Charge in which its influence can be yeah, its influence can be noticed, okay, or let's say put felt. Its influence can be felt by another charge, okay.
Okay.
So this is one thing. Okay, what is the very simple terms for the electric field? Just repeat it again. It's basically the region around any electric charge, okay, where its influence can be felt by any another charge. Is it
Yes, sir.
clear? Okay. Yeah. So how we measure electric field? Again, it's um, how we measure electric field. First is in terms of, okay. Yeah. So first, like we have two options how we can measure electric field. Okay. So it is measured in the form of electric field intensity.
Okay.
Okay. Field intensity, generally denoted by E. It's up to you. You can even change the term, but denoted by E. Okay. It's an
Okay.
vector quantity. Right? Vector. At a similar time, I have another thing, electric field. Potential. Okay. When you write electric field potential is denoted by V. What do you think? Will it be a scalar or vector?
Electric potential.
Yeah. What do you think? Potential will be in vector quantity or
Potential is a scalar quantity.
it's in scalar quantity, right?
Yes.
Scalar quantity. Basically, you can relate it with potential energy, and you know,
Yes.
energy are just like energy is a scalar thing, right? It doesn't depend upon which direction you are moving. Okay,
Yes.
so it's a one thing that it is an your scalar quantity. So we did this part. Now let's start measuring electric field intensity. So that this moves to electric field intensity. So what is electric field intensity? A general idea is you have ease and vector point, right? So what we are going to take,
Yes.
let's say any random point I'm going to take, and from here I'll be having a line like this. This side. I have a charge.
Okay.
Okay, you know, at this point, this charge itself have a magnitude, and itself it has a direction.
Yes.
Okay, so how will I will be calculating electric field at some another point? Are you getting point? What I'm going to do is I have this charge. I'm going to calculate electric field due to this charge at this point P.
Yes.
Okay, so you know what is okay. If I ask you what is force on this P point, can you calculate this thing? You don't know electric field
Force.
right now. That is fine. But if I ask you what is force at this point P, can you explain what is the force at this point?
The formula for force was K Q1 Q2 by R square.
Force will be K Q1 Q2 by R square, is it?
Yes.
But I don't have any. I don't know what charge is it, right? So let's say for okay, if I don't know, let's say I'm calling it as a unit charge. Understood? Unit charge
Okay.
means to say a charge having one magnitude and the unit of coulomb. That's it. This is your unit charge.
Okay.
And okay, let's say this is a very small q charge and remove this as a main charge, as a bigger charge.
Okay.
This is so what your force, the formula for the force comes up as, it
KQ
comes
by
out to
R
be
square.
force equals to kq, not this, kq q by r square. Okay, so this is the force due to this at this point, right?
Yes.
Now just think of it. If I divide the both side by q, the smaller q, what I'm going to get is I'll be getting k q r square. Is it?
Yes.
If I ask you, if you see carefully, this parameter suggests something. Right now, I don't know what it is. But if you see everything in this formula, it doesn't have any relation with this. Is it clear?
Yes.
You can see the k is a constant thing, right? This q is basically the charge of this particle, and this r is basically the distance. This distance can in be this direction also, can in be this direction also, this can be this direction also, because right now I have written it in the scalar quantity. If I had to write in the vector, I can just put r unit vector, and I will say it is strict to this direction. Understood?
Yes.
Okay, so you got something, that I am getting something from it. This something is nothing but your electric field intensity. This something is nothing but electric field intensity due to whom? Due to this cube. Okay, at a distance. Now you also know that if I have a charge, its electric field will be in all the reason, all the sides, like this direction, this direction, this direction. So when I'm saying distance r, so means it means this is the magnitude of electric intensity you'll be getting at any random distance till r. Okay, let's say this is the distance r, this is the distance r, this is the distance r. But if you put a unit vector, you will be getting direction also. Okay, I'm talking about this direction.
Yes.
Understood?
Yes.
Okay. Now, how you can use this electric field? How it is beneficial for you? Any idea?
Electric field.
Yeah. Look, just before what problem we had, right? When I was only aware with the force, at that point I need the value of both charges to do something, right?
Hmm.
Then only I was able to move further. But now, if even if I have a single charge, I can compute its own power. If you see carefully,
Okay.
it is nothing but the power of this charge,
Yes.
right? How much power this has,
Okay.
what is the
Okay. Yes.
intensity
Yes.
of it? Are you getting my point? If I
Yes. Yes.
remove this now, if I remove this from the picture, and if I ask you, okay, what is the power of this at some point, you can directly say, okay, it is nothing but k q by r square. Mean to say, if any another charge comes to this place, the force provided by this will be nothing but this multiplied by q. Understood?
Got it. Yes.
It is nothing but E. So your force formula becomes as E into Q.
Yes. Yes.
E into Q basically, this force is basically, we are right now I'm calculating force on this particle, right?
Yes.
So if you have to calculate force on any particle, what you have to do? You have to get the intensity at that particular point, E, okay? And what you have to do? You have to put the charge. That's it. What you got in this way, you got the force formula. Is it clear?
Yes, sir.
Okay. Any doubt like why we did this divide and how we know it is intensity itself? Did you get
No,
any
no,
feel
sir.
of the
Got it.
intensity thing? Like what is the intensity?
We are just taking the power of the capital Q.
Yeah, you can assume it. Don't say the power because power is again another
Yeah.
thing, right?
Yes. Yes.
Energy in energy wala thing comes up in when we say power.
Mm.
But yeah, it is
Yes.
the strength kind of say you can say,
Yes.
right? Now just assume I'm working in two different pictures. I'll just take two different picture for two different charges. I have one charge having let's say 5 coulomb Q over here, and another charge 10 coulomb. Okay, another Q. Let's say for both I am working on, look, both scenario are on two different situations. Okay, so don't compare at the same time.
Okay.
At some distance I am going R. Okay, at some distance I'm going R. If you don't had idea of electric field, what you could have done, if I ask you, okay, what will be the force at this point? Okay, who will provide the more force at this point? If you don't had the idea, what you need, if you just know the force, you need both things, right? Q1, Q2. You will say, I am not able to say until I get the charge at this point, until I get the another charge at this point. But now you know that I can calculate intensity, basically the strength of a charge at any particular point. So for this charge, now you are able to calculate the strength of this charge at this distance, right? You can calculate. So what
Yes.
is the strength? Basically, you have to say intensity, electric field intensity. What is the electric field intensity? That is K 5 divided by R square, right? For this one,
Yes.
K 10 by R square. Intensity,
Yes.
like more the intensity, mean to say more the force it can provide if I put any charge over here, right?
Yes.
Let's say I put another charge Q, another charge Q. So this scenario becomes as force becomes as like this and this, and you know this is greater than this, right? I can
Yes,
say the
sir.
same thing even without putting the charge. Okay, I can say this is greater. Yeah, so that's fine. Now, if I put a charge over here, this charge will also have intensity at all the sides, right?
Yes.
So, what is the intensity of this charge at this distance? It will nothing but kq by r square. Again, the distance is same because,
Yes, sir.
right? So that's why now you can also calculate force for this. What is it? That is kq by. Okay, what is the
R.
intensity at this point when I put this charge q? Let's talk only about the intensity. That is kq by r square. And
R
here,
square.
wait, just a second. So what is this? Okay, I put Q over, right? So what is the force at intensity at this point? This is already written, right? You can see. So we will be using the intensity at every place. Okay. All right. One more thing. So in vector form, how you can write intensity as F vector per unit charge. You have to say per unit charge.
Yes.
If you see the equation, you have got another definition for the electric field intensity. Electric field intensity is it editing mode? I don't want it to get saved. But I don't know how to. Yeah, electric field intensity can be defined as force experienced by per unit charge. Per unit charge. What it means actually, look, when I had this equation, force is equals to k q smaller q divided by r square, right? So if you see, I just remove this q from here and take it at little distance, like this. So isn't it the experienced by the single charge, right? If you removed it, it is nothing but multiplying by one, right? So it is nothing but the force experienced by per unit charge, like a single charge. Okay. So if you know, it's a very simple, similar to the water or something measurement kind of thing. Like, you need 100 rupees to buy five Coca-Cola. Okay. If this things comes up to you, and I directly ask you, you have to buy 25. You won't be able to tell me how much you need, right? Because you have to just again make another measurement. But if I tell you that one Coca-Cola is of 20 rupees, and if I ask you,
Yeah.
you need 25, how much money you have required? You can directly say 500, right?
Yeah.
Okay. So that's the thing. Just remove this part for now. So finally, what is your electric field intensity over here? Force per unit charge.
Okay.
Sometimes you will see in the books that this q, in the limit, it is written as q approaches to zero. Understood?
Mm.
In some books you will find, okay, but it doesn't make too much sense. It is saying that just the value of the charge we have taken for the test, they are talking about the test charges. Okay. Every time you won't be having this q not going to zero, the test charges they have taken, they are saying is to be the zero. Okay.
Okay.
Okay. And but when you are solving the problem, in that case you are not testing. Okay. So whatever the value is given, you have to put that. Exactly. In formula, when you have to give it as, when you have to present it, right, during a definition, during an explanation, then you can put that. It will look better. So that's
Okay.
it. Okay. Can you calculate the electric unit of electric field intensity?
Okay. Yeah.
SI unit. What can be the
Using
SI
the
unit for
coulombs.
this? Yeah, Newton per coulomb, right? Newton per coulomb. That, that's fine. So, all right, this thing we discussed. Let's go more with type of charge. Let's say I have main charge is my positive. Okay. So what kind of electric field I am going to get? Look, you have to understand the difference. Electric field is the region around the charge where you can get the influence, but
Yeah.
electric field intensity is the particular strength at particular point. Okay, in that field, in that region. Okay. So
Okay.
if my charge is Q, so what kind of electric field I am supposed to get? Electric field due to a positive charge is outwards. Okay.
Okay.
Outwards in all the directions. But at the same time, if I have a negative, what I am going to get? I am going to get inward. Understood? The electric field will look like this. In general, how it is in all the sides outside for positive. For
Okay.
negative, how is it?
Pushing
It is
it to the
inwards.
queue.
So if you see carefully, if I can put, if I can have a negative positive at the same time, how it will look like? Positive,
Both the arrows.
negative. Okay. So this is trying to give its electric field line to someone, and he is ready to accept. So it will go like this. Okay.
Like the magnet.
Because look, one thing you have already, I told you that electric field line never makes a loop. It means it is not the case that it has been started and comes back. Okay, but you also know that if it is going outside somewhere, it has to go, right? Somewhere it has
Yes.
to go. But if you see another positive charge, this positive charge is not ready to accept. It is trying to pull out, right? So in this case, it will go like this, but it won't
Yes.
intersect or it won't merge each. So to go somewhere else, they have negative charge. Okay, so you can say it starts from positive, it ends up at negative, like this kind of scenario you can see. And maybe for this also, maybe for this also, going outside, and here also it is taking taking, but yeah, it should be negative to do this. Understood this part? Okay, so
Sorry, I was muted. Sorry, sorry.
hello, what happened?
I was muted.
You were
I was muted.
okay, you were muted. Oh, fine, fine. Okay, now you got unmuted, huh?
Yes, yes. I understood, yes.
Understood. Okay, fine. Now what's the task is, okay, if I have positive charge over here, if I have a negative charge over here, what do you think? What will be the direction of force from this positive to negative
The charge will go away from positive to the negative.
charge? No, no. Look, what I'm saying is,
The field.
uh, look, electric field. I'm not asking what is the direction. Like electric field, you will say this, and it will be like this. Is okay?
Yes.
No, I'm not asking. I'm saying what is the direction of force.
I still don't understand.
Okay, let's say this is the one who is applying force, right, on this
Yes.
charge. So in this, what will be the direction of force? Will it be this or will it be this?
Oh, it should be the opposite of the positive charge.
This one.
Yes.
Okay, fine. Yeah, it will be the same, right? The reason behind it, if I ask you what is the electric field, look, if I ask you what is the force, now you know how to calculate the force. Force is nothing but electric field at this point multiplied by the charge itself, right?
Yes.
Charge is negative, so I can put like this. Okay, what is the direction of electric field? You can see the direction of, okay, better is make this like x unit vector and this is y unit vector. Okay, so we'll be taking the directions using these format. Understood?
Okay.
So if I ask you what is the direction, so electric field is nothing but in the direction of x unit vector, and you got minus. So if you merge it again, what it will look like? It is like q comes here, e is here, and what is the final direction? It comes out as minus x. Understood?
Yes, sir.
What it becomes? It becomes this direction. Yeah, this
Yes,
direction.
sir.
Okay. Now I just want to calculate the same thing but in opposite sense. For this one, what is the force on this one? Again, force is nothing but electric field's direction and charge. Here the charge is positive. But what is the electric field due to this? Electric field is towards itself, right? So for this point, what will be the direction of electric field due to this one? It will be this, right?
Yes.
So I'll just put the magnitude, directly magnitude over here, and I will put the direction. Okay. If you are not putting the magnitude, you can just directly go with the values. Okay.
Okay.
Here, what I will directly put the final value of it. What is the direction? It will be this and minus x, or it will be x. What do you think? Now what should be
My
the direction?
X
Yeah, it will be
minus.
X, right? No, it will be X because look, what is the electric field direction due to this? It has an intensity in this direction, right? The negative
Yes,
charge have inwards, so it will become X only,
yes,
and here it will become Q. So if you see carefully, what you got, a Q E times of X. If you see carefully, the value is still the same. The only thing which is difference in both, that is the direction. Okay,
direction.
now you understand why we say that negative, like opposite charges attracts. How? Look, this charge is applying force, like this charge is applying force on this one towards himself,
Yes,
right? You can see in the extraction, this charge is applying force on this one towards himself, where in this direction, and this direction is nothing but x negative, and this direction is nothing but x. Understood now?
understood.
Clarified? Okay. Yeah. So this is one thing. Um, should I go through the vector form of it also, or it is fine?
It
Let's
should be
go.
fine. Is it the same as we did yesterday?
Yeah, it will be same. Just you have to look. What was the electric? Let's write. I'm writing for the force. Okay. And look, now I won't be writing the unit vector in the form of this and this. I'll directly put x. Right?
Okay.
It will be in better option. So force is nothing but k. You know one q. You know another q. You can assume one to be this to be positive, this to be negative. Don't have to write this thing. Okay. And the r vector. Okay. What is the force? Let's say the force is x. Okay. Let's say the force comes out to be x. Mm, so what we can do here? If you have to find out the electric field, what you have to do? If you are finding out the electric field due to this q charge, right? Basically due to this charge, it means you are checking on this one. Is it clear?
Yes,
So you just have to remove this k q r square divided by this vector.
yes,
Clarity.
yes.
So these things are there. You have to study.
Okay.
Okay, fine. Any doubt in this electric field wala part?
No.
No, right? Okay, I look for some problem if any I have. So I'm just sharing one problem. Uh, where this goes. Where's my page? Here I can put. So this is the question, and we are corresponding some equations also. The graph which is provided by this one. So this is the graph associated with this one. Okay.
Okay.
Yeah, so this is the net problem we have to take. It's actually a good problem. You can. Okay. So what you have to do is, I'm giving you 3 minutes. You can try and understand this problem. If you want able to do, I will explain it. Okay.
Okay.
Yeah. So I'm giving you 3 minutes to solve.
Can you show the question, sir?
Yeah, I'll just this is,
I'll just take a screenshot.
no, no, yeah, you can see. And I will just check it. Okay.
Okay.
Uh,
Hello?
hello. Yeah.
Yes, sir.
Yeah. So did you solve it?
I have tried.
Okay.
So in the first one, I think the A should be negative because the electric field is decreasing.
Okay.
Then, as
Look,
it is
in the
continuing,
first one, both should be negative or one of them should be negative. What's the case? Like A and B are given, so you can say like A is this and B is this in this form.
uh, I think both should be negative.
Okay.
I'm not so sure about B.
All right. Okay. So for this one, you are not sure. For this one, you are saying that both are negative, right?
No, no, for the no, no, sorry, sorry. In A part, the A charge
Okay.
should be negative,
I put the
but
negative.
in the yeah, and the B one should be negative. I'm not so sure.
Okay. So I'll just put the country. What about the remaining three?
Uh, A should be positive and B should be negative.
A should be positive and B should be the negative one. Okay. And what about the rest of the twos?
Uh, A since E is increasing,
Okay.
increase.
Should I solve it?
Yeah, I'm just confused a bit.
Okay. Let's leave it. Okay. So how did you solve this one? First one. First, my question is this: how did you try this problem?
I thought to use the formula, and the electric field is inversely proportional to the radius, the distance.
So I'll just go one by one. If you see this graph, this question, so if you see this is the charge, right? And near to this charge, it is let's say going high, very high, right? Like if you what you can see, electric field is nothing but k, the charge itself a divided by r square, the distance, right? Is it Is it the electric field, right? Hello. I'm not audible or what? In this. Hello, Pratham. Am I not audible? Hello, Pratham. Is it audible or not? Let me know.
Hello.
Yeah. Hello. I think now is
Yes,
it clear? Okay.
I got disconnected.
Yeah. So look, this is the first charge A. This is the another charge B, right? So
Yes.
if you see carefully, what is the distance of this A with itself?
Zero.
Look, first of all, this R is basically the distance is given, right? So it means this A is over here, and if I'm checking about electric field at this line anywhere, it means I'm checking the electric field on the charge itself, right?
Yes.
Electric field due to this, let's say due to this, I'm saying this is the line, one line, although there it is going all the directions. Due to this one, if I have to calculate any point, let's say this is the random point x. If I have to calculate any point x, I have to put this formula, right? Let's say put this x.
Yes.
So if you see carefully, when I'll be calculating this on its this axis, because this curve is based on the electric field value from this to this. It means when my distance is r, basically you can see instead of calculating here, I'm calculating it at the charge itself. So instead of this, I have to put zero. Is it the case?
Yes.
And you can see this electric field is going towards the infinity.
Yes.
That you know very well. This is the magnitude we are talking about, right?
Yes.
But we have to figure out what is the nature of this charge. How I can say that? If you see carefully, the electric field is going infinity. That is fine. But in which direction it is going? If you see, this is going in the positive
Up.
electric field, right?
Yes.
This is positive thing. This thing comes out to positive. So and the rest thing is A. So if it is going towards positive, I can say the charge A is positive over here. Is
Okay.
it clear? Alright. For this one, if I see, okay, what about this one?
Again positive.
Again positive, right? Why?
Because it is going in the positive direction.
Because it is
Above
going in the
and infinity.
positive direction, right? So it should be positive again. All right. I will just try to check. Okay, what about this part? Just check this one.
C part.
Yeah.
The charge is going in negative direction towards infinity. So A should be negative.
A should be
Negative. Negative.
A should be negative. Okay. And what about the B?
Uh, B is also going towards infinity in negative direction. So it should be
All
negative.
right. Okay. Does the question says anything else? All right. What about the B and D?
I can't see the B part. In the D, it should A
Okay.
should be positive,
A should be
positive, and B should be positive.
A should be positive and B
No,
should be
sorry,
positive.
sorry. Yeah, A should be negative and B should be positive.
Yeah, that's fine. Okay, and what? Look, one thing. In the D part, I'll just go with the D part. D part, both of them are negative.
Okay. Why?
You have to think that thing. Look, one thing. This, where's this? Yeah. If you see carefully, this is A, right?
Yes.
What is the distance between we are look right now at what distance we are checking over only this distance, and you can see electric field is directly negative, so I can directly say this A is going to be the negative. Is it clear?
Yes.
Okay. What about this B thing? Why this thing comes out to be positive? That you have to think of it for a while.
Why does B comes out to be negative?
No, yeah. Why this B also comes out to be negative? That thing you have to just
Uh,
guess it out.
uh, the curve is
Okay.
somewhat same like the first part.
Look, I can just give. I look the thing how I give hint for you this one. Na, I can
Yes.
give hint for this will be the positive. Okay, and similar to this will be the negative. Okay, I have rest the B part for each of them. Can you solve this one as a homework part?
Okay, so I need to figure out why the B is not going
Yeah,
according to what I'm saying.
yeah. Like what you are thinking now, that is fine. But B is not only dependent on itself right now. We are thinking, okay, there's its influence is also there at this distance.
Okay.
Okay, so you have to think of this part also. Okay, so now I can say that I'll just saying this is positive, this is negative, this is also negative, and this is also positive. So just think of the B part. Okay. All right. Just take it as a homework. I'm not telling you the answer.
Okay,
Understood?
okay.
So this is the thing. One more question was there. I think I probably. This is a basic question. So where is it? I think it is not there. Okay. So what I'm saying is, we have done some basic things till now. So instead of going to the next, we should go with the questions better. It will be better option to go with the problems.
Okay.
So yeah, solve this one. The answer in for this one you have to give in the numerical form basically, in the
Okay.
format of 10 to the power x. Okay, or
Okay,
better
okay.
I can say that the okay I'll just type in the answer. Answer is nothing but your 10 to the power x. You have to get me the value of x.
Okay, okay.
Okay, so this is your question.
Mhm. I need to find the acceleration.
Yeah,
Okay.
look, acceleration. I'm saying the answer is 10 to the power x. You have to get me
Yes.
the value of x. Okay. Maybe it is not the sure that you will get directly 10 to the power x. If you are getting something 1 point very very something, you can assume that to be the x. Okay.
Okay, okay.
Thank you, sir.
Do I need to convert ampere to meter?
Ampere to meter.
Yeah, the distance in meters.
Okay, yeah, Armstrong. Yeah, you have to convert that.
Yeah, Armstrong, sorry, yeah, Armstrong.
That's what I thought. Okay, you have to convert that Armstrong to meter.
Okay. Can you help me with that? I forgot.
The conversion, right?
Yes.
10 to the power minus 10.
Oh, okay.
For some, I'll just write. You can take them.
AM. Okay. So shouldn't the mass of proton also be given?
Shouldn't the
Chart.
mass of
Sorry, wait a second.
look, the thing is
The
not the problem assumes that you already know the properties of these electrons and protons, or if you
I,
could
I,
remember, we have already
I just
discussed
got
the
it.
same thing in the first class also, right?
Yes, yes, yes. Charge radius. Is the answer uh, I have to calculate the powers. Just give me a
Okay,
second.
no problem. You can just calculate the power and let me know.
Minus 10 is to minus 9 or 10 is to minus 31. 31. Is it 22?
Yeah, that's fine. Okay, so answer is 22. So you can say the final answer is around 10 to the power 22. Okay,
Yes.
and we are talking about acceleration, so I can say Newton plus. What?
Yes, yes.
You want me to write the solution or it's fine?
No, no, I got it.
Okay.
First we, yes.
Yeah.
First we found the force, then we applied F equal to L.
Calculate the force. Force. Acceleration equals to F by m. The mass of electron, I think we have to work, right? So yeah, the
Yes.
mass. Is it the electron? Okay, yeah, that's fine. Force I got, when I got the force, I just have to do this. K, Q by R. So this is what you had to do. Is it fine?
Yes, sir.
Okay. Yeah. So this is all for the today's class. Okay, it's already done. What I'll suggest you look, the electric field topic is very important topic, right? So at least try to solve 10 problems if you have. If you don't have, let me know. I will give it to you 10 problems if you want.
Yes, sir. You can share the problems, then we can discuss in class if I
Okay.
have any issue.
So the first task is you can solve this one. Okay. This itself a good thing because you will understand the graph thing. You can understand the how you have to make the graphs. Yeah, how you have to play with the graphs.
Okay.
Okay. All right. So this is the one thing, and another you can. Okay, you have questions, or I can paste it over here. Any questions? Yeah, you have problems, or I have to paste it over here. Some problems I can paste.
You can share it to me on WhatsApp, I think.
Okay, I'll try to share. Or okay, do one thing. If you have, you can solve it by yourself. At the end of this chapter, I'll share you many questions. Okay, or we will solve it in the
Okay.
class. Okay, problem solving class we will take. And if okay, one more thing. If you feel any doubt now, either collect that question as a like take the question and ask me, or if either collect it, we'll be having one class as a problem solving itself, and you can ask all those questions. Okay.
Okay.
Yeah, so that's fine. Okay, one more thing I have to ask. In the Saturday, like, can you take the class in the morning or afternoon time?
On Saturday, actually, I have my coaching.
Okay.
So I am not available between 8:30 and 4:30.
No, no, I'm not. Okay, 8:30 to 4:30, you are not available, right?
Yes.
Okay. Okay, leave it. We'll take it to at the 6:30 at the this time itself. Okay.
Okay. So I was asking if the timing could be shifted to 7,
Time could be shifted to 7.
if it's possible.
7 to 8. Yeah, it can be. Actually, it's possible.
I'll talk to ma'am, Manisha ma'am, then I think she'll let you know.
Okay, fine. So we can shift
Thank,
it. Okay. That's fine.
thank you, sir.
Okay. Goodbye. I'll just send this issue.
Okay.